Hi, in this video, I'm going to show you how to do a simple demand forecast model. Let's first go to the sample list of data sets. Let's pick this bike rental data set, visualize it. You see this is a time series. Each row is 1 hour of data. It has year, month, hour, whether it's a holiday, weekday, the day of the week, whether it is a working day, and the weather situation. In terms of the weather situation, you see there are a total of 4 values, meaning there are 4 different types of weather conditions. And then we have values like humidity and wind speed and stuff like that, and temperature, 4 columns. These are numerical columns, and they are normalized. That's great. So we don't have to do normalization. Since this is just a demo, it's okay. In real life, we will have to go through normalization and also to look at missing values. But for this data set, there isn't any missing value. You can look at here. The missing value is 0. And then the last 3 columns, casual, registered, and count. These are the labels that we are supposed to predict. Count means how many total bikes were rented out, I think. And this 16 comprises 13 registered user and 3 casual users. Means 3 bikes were rented to casual users and 13 to registered users. So the total count for this particular hour is 16. So given these information, we are supposed to predict this column. All right. Let's see how we're going to do that. Now, first thing we have to do here is to select the data, the columns that we want. So I will go to search, select columns from data set, like that. Join these 2 modules, and then click the launch selector. Now, there are a few columns here that we don't need and some that we cannot have. Like this instance, we probably don't need it. DTE day, we don't need it because it is the same information is contained in this year, month, hour information. So I take from season all the way down to wind speed. And then I have to also choose the count because that's the label. Now it's very important for this particular data set, we don't choose casual and registered. And the reason is that these 2 are the components that form count. Therefore, if we were to use this as a feature, the model would definitely be able to predict this. So that is not right. Therefore, this 2 has to be left unchosen. So I click yes. So the next thing that we have to do is to split the data to train and test. So I come here and do split. So there's a module here called split data. Choose that. So this is the case. Now, very important for time series data, we cannot use random split. And the reason is that we cannot use future time slot to predict past time slot. That's leaking information. In real life, we can never see into the future. Therefore, in our training, we must not have a train set that you are able to see future data. So the better way to split is by doing this relative expression. And then we are supposed to give a column and a condition. Let's see how do we split the data for this time series. Now, one way to split it is to split it by time, meaning that you choose time slots that are before for train and time slots that are in the future for test. So you have year 0 and year 1. So I can make year 0 the train set, and year 1 the test set. So in that case, when we train the model using the train set, we are not given anything that is after in the future when we do the validation. I hope this makes sense. So in order to do that, what we need to do is come here, change this to year, and we said equals 0. It's very important that you put two equals here because it is a condition. It's not an assignment. If you put a single equal sign, it becomes an assignment. So now what we are saying is that if the value of year is equals to 0, assign that to data set number 1. Data set number 1 is here. We will make that the train set. If it is anything else other than 0, then assign it to data set number 2, which we will make it the test set. So let's run that. Okay, let's take a look. Now this is data set number 1. So now it comprises only rows where year equals to 0. See, min, max are both 0. There's only one value type, which is 0, right? And we started off with over 17,000 rows, and now we only left with 8,006, so it's about half of it. That's correct. Let's go here, visualize. This will be the test set. Okay, so it again only have one value, which is 1. That's exactly what we want. So therefore, we will be training with data that is year 0, and then validating or testing it with data that is from year 1. Therefore, these are totally separate. There's no leaking of data from one set to another. Next, we need the train model. Okay, let's put it here. And then an algorithm. For this demo, let's use something really simple to start. Linear regression. All right, linear regression. You see two connectors here, and when you mouse over to the left, it says untrained model. This is where you want to connect the algorithm to. And then here it says data set. That means you want the trained data set to be connected. So this is a trained data set, connect to here. The next thing that we will need to do is to specify the label column, meaning telling the model which column here you want to predict. And we want to predict this count, so we do it here like that. Okay, and the next thing we need here is a score model. This module will take the train model and then do a scoring, do a prediction. This is an inference model, and inference using the test data set, which is from here. So we need to connect like that. And then last but not least, the evaluation model. Oops, eval model. Right here. So the output of this score model is a prediction, and then connected here, the evaluation model, the evaluate model will then do a evaluation how good the performance of the model is. So we are done creating the structure. Let's run it. Okay, it's done. Now let's just take a look at the score model first. Visualize. To the right, you see a scored label. These are the prediction. So the actual count is 48. The prediction is 13. It's not very good. 93, 19. So this is not a very good model. It's okay. This is just our first try. We'll see how to improve it later. Let's visualize the evaluate model. you can see that the root mean square is 192. Now this is the number that we want it to be as small as possible. In the next few videos, we'll look at how we can improve on what we have done so far.